Let me explain to you the concept of bioresilience. Bioresilience is a different way at viewing biology than our customary view, which is biodiversity. Through the lens of bioresilience, we can see a new way of understanding the strength of life. In bioresilience, the core dynamic at play is energy. And the differing ways that life manages and uses energy creates the strength in those life forms. Now, in the customary view of biology, which is measuring life and documenting life based on biodiversity, the formative factor there is genetics, the different genetic streams that create life forms. It's DNA. And so when we have multiple types of DNA present, we have multiple species. And the conventional view, which is true, is that more species creates greater biological strength. A more diverse ecosystem is considered to be a stronger ecosystem. But when we look at life through the lens of bioresilience, we can see that there is a parallel, equally strong method of understanding life itself. Energy. Life is energy. The minerals that constitute matter through energy became alive. The question now is, how do we understand that materialization of life from matter? In the concept of bioresilience, we can see that life has learned to adapt in differing ways depending on the availability of energy. Bioresilience gives us a way to measure this dynamic of the energy of life. Through measuring the life itself by its capacity to respond to energy, we have a means of understanding the capacities of the life systems involved. Bioresilience shows us that life in one species can be extremely hardy. That single species has learned to respond and adapt and live productively in a variable energy environment. Whereas in a biodiverse situation, there is no need for that species to have that capability of adaptation, because the environment is very stable. And with the stability, the species can evolve with new characteristics that we see in its habitat niches that species can adapt to. Multiple niches, multiple species. Whereas as we go into more hardier, when we go into hardier energy environments, those species need to be able to adapt across the energy spectrum. Bioresilience and biodiversity work together on our planet to give planetary life strength. And therefore, we see around the middle of the planet the belt of biodiversity in the equatorial and the subtropical zones, where this greater resilience, genetic resilience, is found. But when we move to the poles at the edge of the planet, where the variability of energy is extreme. Then we see fewer species, but each species is able to adapt to that diversity. The mountains of the world compress the planetary diversity. Where we have the diversity of species ranging from the tropics to the subtropics to the alpine to the Arctic across the whole pole, where we have that representation across the whole planet. On a mountain, we have that representation on a single hillside. What does this mean? This means that each individual life form, each species of life, has to be able to extend across the spectrum of energy. It has to be able to live at night, when it may be freezing. It has to be able to live during the daytime, when it's very hot. It has to be able to unpredictably change. Because when the sun goes in with a cloud, suddenly the dynamics are different. But when the life forms are living down lower, that variability is cushioned by the blanket that is air itself. And this allows life to be able to grow with the diversity of the genetic dynamics. Eventually, as we go higher and higher and higher, that spectrum of energy becomes so great that life cannot exist. But typically, life is resilient and figures out ways to accommodate this diversity. So what happens is that fewer numbers of species are found here in the temperate zone than we would find in an equivalent small radius in the subtropical or tropical zones. And if we go higher into the alpine zones, we will find even fewer species, a few types of grasses, and not the succulents. Because the succulents are susceptible to the freezing and thawing cycle, and so their vascular systems have to be able to accommodate, and by the time we get higher, they are not able to accommodate so quickly to the diversity and changes in temperature. We can see a 100-degree variability, 100-degree Fahrenheit variability, a 40-degree Celsius variability in one day, between night and day. When we start to reach these altitudes, and when we get higher, the variability in temperature becomes even greater. If we are to have a future that is healthy and productive as a planet with all of its interlinked systems of life, we have to look at both the genetic base of life itself and also the energy base as measured by bioresilience.